Algebra 1, Section 6.2, slope-intercept form. Everybody's favorite, home base. I say that somewhat facetiously. I want you to not see things that way, but rather see the value in all three of these forms. I know I said that in a previous video, but that being said, 6.2 may well be the one you're most comfortable with, the one you've spent the most time with. It is the easiest one to graph out of, I admit, and that's why it's called slope-intercept form, because to graph a line, one of the easy ways to do it is to find a point, in this case the y-intercept, and then use the slope to go from that point. Slope intercept form, that's why it's called that. Okay, now as we said in the previous video, m for point slope was the slope itself. That's the same thing with slope intercept form. M is the slope. B is what we call the y-intercept. Now a quick word about the y-intercept. It's not some random thing. It's not some math nerd decided, hey, we'll call B the y-intercept. The reason that B is the y-intercept, as you saw in section 6.4 when we were plugging zeros in for certain variables to find the intercept of the other variable, plug in 0 for x to find the y-intercept, plug in 0 for y to find the x-intercept. If I plug 0 in for x here, you're left with just b, right? 0 times m is going to be 0. That 0 plus b is just b. The y is going to be equal to b when x equals 0. The y-intercept is that b value. That's why it's called the y-intercept, okay? So again, it's got a purpose. Graphing is kind of its main feature for slope-intercept form, and we can pick out the slope and the y-intercept from something that is in point-slope form. So what are the slope and y-intercept of y equals 2x minus 3? The slope would be 2, the y-intercept would be negative 3. You ought to be able to do that pretty quickly. Pick it right out of the equation. There's the slope, there's the y-intercept, including the negative. That means that it would be crossing the y-axis at negative 3, and you could graph a slope of 2, something like this, and away you go. I'm sure we'll do that here in just a minute. The slope is 2, the y-intercept is negative 3. Write an equation of the line with slope 2/5 and y-intercept 4. I'm going fast here. If you want a little more time to process, make sure you pause the video. This is going to be in y equals mx plus b form, slope-intercept form. Because they gave us a slope and a y-intercept, it is just very natural to use this form, and it would be y equals 2/5 x plus 4. Okay, moving right along. Write an equation for the line. Now they give us the graph and they want an equation for the line. Just the same, it's probably easiest to use slope-intercept form, assuming we can get a good number for the y-intercept. Yes, you could use point-slope form. Yes, there is a standard form for this equation, right? The previous two lessons. But what's obvious is obvious, and the y-intercept here is 1. It appears that the slope is down 2, right 3. That would be a slope of negative 2/3. So y equals mx plus b. I just said a slope of negative 2/3. A y-intercept of positive 1. We write y equals negative 2/3 x plus 1. There should always, as we said in the last video, there should always be an x and a y in your answer. Y equals negative 2/3 x plus 1. And then they'll ask us to graph. Now again, as I roll to the graph, they may already kind of give it away, so let me not give that away yet. Y-intercept of negative 2, a slope of 1/3. Can we plot the point negative 2? There it is, okay? The slope of 1/3 means rise over run. That's up 1, right 3. Up 1, right 3. There's an x-intercept at 6, just for your information. And then we could also go down 1, left 3, right? Down 1, left 3 is the fraction 1/3. The slope is still 1/3 when I go down 1, left 3. Notice they all lie on the same line. And there is that line. Again, with the graph paper that I provide you, it's going to be wider. You know, this arrow is going to go out to here more, and it's going to be negative 10 to 10, a bit bigger. Draw a nice long line that spans the graph, please. Use a straight edge too. Be wonderful. All right, lastly, the base pay for a used car salesperson is $300 per week. The salesperson also earns 15% commission on sales made. The equation T equals 300 plus 0.15 S relates total earnings T to sales S. Graph the equation. Always be careful with the variable S. I may have said this in class a few times. I always just point this out. my S's can kind of morph into 5s sometimes. So be careful if you're going to use the variable S. Also, I don't really think they needed to give us this equation. I think they gave us enough information to do this ourselves. Total earnings is $300 no matter what, right? This is what this person makes per week no matter what, plus 15%, right? That's this number here, as a decimal is 0.15 of the sales. Okay, now I know I just rewrote what they already had there, but I'm trying to explain what this is. So this person is going to make above $300 if he or she can make a sale, and it's 15% of that sale. Okay, so to graph this then, we would want to, and by the way, T equals 0.15S plus 300 is a little bit more closely aligned to y equals mx plus b, slope-intercept form, putting the variable term first. The y-intercept would be 300. Now think about that. If I were to graph this, and the y-intercept is 300, and it's going up from there, maybe I go by 50s, 50, 100, 150, 200, 250, 300 would be the first place where I could plot a point. And then without putting a scale in here, just know that this is going to go up from here. Wouldn't you say there's a lot of wasted space in this area right here? There's a whole lot of wasted space. I don't know if you've ever seen this before. If you haven't, they're about to show it. What you could do to graph this is put a break in the graph like this, okay? And then you'd be all right to start. I didn't really do that right. Let me do it again. I just erased everything, but here's what we're graphing. Put a break in the graph like this. It's just really a scribble. I'm sorry, I'm not showing it very well because my starboard just doesn't work like that. But it's like a scribble in the graph that says, hey, all this is wasted space here, so just go ahead and start where you like. Now, you still need to have a consistent scale. If I decide to start at 300 and then I want to go by 25s, here's 325, here's 350, here's 375, here's 400. You still have to have a consistent scale. You just don't have to have this much of it aligned with 0. Yeah, here's 0, and there's a whole bunch of space that gets kind of condensed into this broken graph, and away you go. I'll show you what they have as their final product here. This is what that scribble really should look like. The starboard just doesn't want to work for me as well as I'd like it to. Okay, that's a broken graph. Notice again, they are going consistent. I'm not crazy about the scale they've picked here. If this is 15, then this is 7.5, right? So 307.5, 315, 322.5, 330, 337.5, 345. But anyway, they have plotted a couple points here that would model the equation that we had already given, and then draw a line. Okay. Again, I think they could have used a better scale there. Think about this. So they plotted the point $100, and then $315 is the salesperson's pay. How many car salesmen make $100 of sales in a week? I mean, don't you sell cars by the car? Now, I'll tell you the story about the car that I bought for $50 once, but that was rare. Okay, you're not usually going to get a car for $100. So it probably would have made more sense to go like by thousands in sales, even if you're a used car salesman that sells junkers. you go onto the junker lot, you might find cars for 1,000 or more. Anyway, so make this go by 1,000, and this would be higher numbers too. Good enough though. Thanks for watching.